Hey, Nathan here. Welcome to a brand new series. This series, we are going to extend the artificial intelligence series and go back to the concepts we have discussed before and implement the additional features that I mentioned in the original tutorials. And then we'll cover more advanced topics, things like priority-based artificial intelligence and finite state machines and those kind of concepts. So the original video game artificial intelligence series, we just did the very basics of like seeking, wandering, obstacle avoidance, and hiding, and those kind of concepts. And when I did those tutorials, it was a basic introduction to those concepts where in the future down the line, I would extend on those concepts. For example, wandering. In order to prevent the object from wandering in the same location, it would be influenced by going to locations that it has never been to before. Like if it's circling around on the top left of the screen, we want to influence it to focus more on the bottom right and kind of push the object to the bottom right or bottom left or top right, places that it hasn't been to before. Things like hiding. If the enemy's field of view is obstructed by an object, there's no need to hide. We want to build on these artificial intelligence concepts with a more advanced approach. The very basic concepts I've discussed in the previous tutorials were a basic introduction to the concepts of wandering, hiding, obstacle avoidance, and those kind of things. And then we'll get some fresh concepts like the finite state machines and priority-based artificial intelligence, where we will choose a random item in the priority of what to do in certain situations. And then we'll go into like fuzzy logic and more advanced topics. So this is going to be similar to the previous video game artificial intelligence series. This is going to be the first in my split series approach, where this is going to be straight to YouTube while I work on the content that I'm like the DirectX 11 and Intro to C#, while I get those completed and upload those to my website, and then we'll wait on releasing those to YouTube for a while. So this is just an introduction to the series and what the series will cover. Just a quick video to discuss that. And this is going to be straight to YouTube, so expect a weekly or bi-weekly release of these concepts. Very rapid tutorial release schedule for this series, since it's going to be straight to YouTube like I've done in the previous series. Alright, so first up, we're going to do a quick look at finite state machines. We're going to take a very abstract look at one of my favorite games to kind of, I don't have the source code to the game, so I can't guarantee 100% that this is what's going on, but to look at the game and to think about a finite state machine as the game is running. They might not even use a finite state machine, but to illustrate my point, we can kind of look at the game and see we can create a finite state machine of what's going on. So I think that'll be a pretty fun thing to do. And then the one after that is the one we're going to discuss, wandering, with the influence of places that it's never been to before. And we're going to approach that by splitting the game world into a grid. The places that the object has been to, we'll mark those as inactive, or places that it's been to. It'll probably be easier to just have an active-inactive switch on the object itself. And then only the tiles, only the parts of the grid that are active, will influence the wandering artificial intelligence. Now, there's still going to be a chance that it's going to go to a place that it's been to before. We don't want to force it too much to go to a unknown place. For example, when we throw in obstacle avoidance on top of that, that's going to be a higher priority. We don't want to run into a bomb or something. It wants to avoid those objects at a much more higher priority than going to an unknown place. So that's going to take precedence. We just want to influence where the object wants to travel. We don't want to force it too much, because then it will just result into a chaotic mess. We'll let wandering do its thing, and then we will influence it. And then I'll explain more in depth on the mathematics behind it, much more than I did in the previous video. This series will have the same approach. I'll implement some pseudocode so you can implement it in a Python game, a Java game, a DirectX game, or whatever. But the actual solution will be monogame, C# and monogame. But I will have a pseudocode included where, like I mentioned, you can implement it wherever you want. You might need to make some adjustments or things like that, but you'll get the general idea of what the algorithm is doing by the pseudocode. Alright, so that is it for this video. I hope this new series will greatly extend on the previous artificial intelligence series and make these very nice concepts and very nice algorithms that you can use in your game. And we're going to actually build a artificial intelligence library in this series where we will have an entire behavior system where wandering will inherit from the behavior system. A finite state machine will have like a brain, where a brain which will control the state and that kind of thing. So as we go along in the series, we can build a game library for artificial intelligence. And I'll call that PH Studios Game Library AI. So PGLAI. And that will be another add-on to it'll be a different one, or I can include it. I haven't decided, but it will be a part of the PGL2D and PGL3D libraries as well. Alright, so thanks for listening, and expect a rapid release for like every week or every 2 weeks. Stay tuned for the next one, which will discuss finite state machines and take a look at a concept of an actual video game. One of my favorite video games of all time.